Excellent, you're back. The E2 mechanism, we're going to go through the motions as we usually do. We mark our alpha carbon. We also mark our beta carbon. And the other thing that we need to do for an E2 reaction is that we must have a strong base. Now, the strong bases that we use are usually alkoxides. And in terms of alkoxides, we're going to use the sodium ethoxide, or we're going to use the bulky base, the potassium terbutoxide. So we have a carbon that has 3 methyls and it's been deprotonated. Now remember that sodium and potassium are counter ions, so that means that the oxygen that's next to them, they have a negative charge. So these are the 2 bases that we regularly use for E2 reactions. But let's just do the E2 mechanism. The E2, the number 2 means that it's a bimolecular reaction, and this one is going to be a concerted mechanism. So what we are going to do, I'm going to take this hydrogen that's on the beta carbon and I'm going to extend it at the very top, because our base, let's use the ethoxide. Our base is going to go to the beta carbon and it's going to start attracting that proton at the same time that I'm forming a double bond. Remember, this hydrogen is not there anymore. At the same time, we're forming a double bond between the alpha and the beta. And at that same time, you know what we're doing to the leaving group? We're kicking out the leaving group. We don't call it kicking out. You actually say you're displacing the leaving group. But the transition state for this mechanism, you don't commit to anything, basically. If you're making a bond, you are going to put dotted lines. If you're breaking a bond, you're also going to make dotted lines. So we are making a bond between the negative oxygen, the alkoxide oxygen, and the hydrogen. We're breaking the bond between the carbon and the hydrogen, and we're using those electrons to double the bond between the carbons. And at that same time, I'm also breaking the bond to the leaving group. So this right here is a transition state for the E2 mechanism. And there's 2 molecules coming together, so the rate of the reaction, since this is the rate determining step, the rate of the reaction is going to depend on the concentration of my base, of my strong base, and the concentration of the alkyl halide that I have. So the reaction, the rate of the reaction depends on the concentration of 2 molecules, and that's why it's a bimolecular reaction. Eventually, of course, I will finish making and breaking bonds. So now I have a double bond right here. We're also going to get the alcohol because our base just picked up a proton. So now it's an alcohol. And we have the bromide in there. And if you are worried about the fate of bromide, don't worry, you'll find the sodium. But what we care about is this double bond right here. Because depending on which base you're using, you can get the more substituted double bond or the less substituted double bond. So go find the video that talks about which base forms the most substituted double bond and which base forms the less substituted double bond.